example 14, we're given a typical question on regression, right? So in this particular context, we're looking at the average densities of blackbirds over a large area of either farmland or woodland. Alright, so in the table it is given the values of the densities of the blackbirds in farmland density given by y and woodland density given by x, okay, throughout the years from 1976 to 1982. In this question, you are actually told that counting blackbirds in the woodland is actually easier than counting them in farmland. In part 1, you are asked to estimate the linear regression equation of y on x relating to the farmland and woodland densities. So if we look at the requirement of the question of y on x, so if y on x, right, so usually you will need to roughly write out that the regression line will be of the form y equals to a plus bx. Alright. In part 2, then you are asked to find the product moment correlation coefficient, okay, r, and then you are asked to comment on this value. Now in part 3, you are given that the woodland density is 1380 or 500, and then you are asked to estimate the average farmland density for that year, and you are asked to comment on the reliability of this estimation. Right. On the last part, okay, you are asked to comment on the appropriate use of a regression line. So you are asked to think about whether you should use y on x or x on y, right? And this must really depend on which of the variable is the dependent variable and which one is the independent variable. So let's look at how we can actually solve example 14. Alright, so from the GC you would have already obtained this set of results, right? So it is very obvious here that for y on x, in this case, you are trying to get the regression line which is represented by y equals to a plus bx. Alright, so it is easy for you to observe from here that this is your y-intercept, and the gradient for the line is in fact your b, right? So the regression line is given as this. With this set of results, so you are able to find the product moment correlation coefficient, right? And the value is 0.907. So at 0.907, we can actually say that there is a strong positive linear correlation between the average densities of blackbirds in the farmland and in the woodland. Just to maybe refresh ourselves, we represent our woodland by the letter X, alright, and we represent the farmland by the letter Y. Alright. Now, in context of the question, what does it mean? What it means is, it would suggest that as the average densities of the blackbirds in the woodland increases, the average density of blackbirds in the farmland increases. And how do we know this? It is very observable from the equation of the regression line that we have just obtained. Now in part 3 you are asked to predict the value of the average farmland density of the blackbirds, alright, given a certain value for the average woodland density of the blackbirds. Now, before we actually handle this question, we need to be observant enough to know which variable is the dependent variable and which variable is the independent variable according to the context of the question. Now, if we trace back in the earlier part of the question, it is said that the counting blackbirds in woodland area is easier than counting blackbirds in farmland area. So if you were to read this part of the question, you would have some kind of inkling that actually the woodland blackbird density will be the one which is the independent variable, whereas the farmland blackbird density will be the dependent variable. Alright, and that is the reason why we actually find the regression line of y on x. So in part 3 we already know that the regression line of y on x is given by this. We found this earlier. So with a given value of 380 for the woodland density, we will be able to use the regression line to find the farmland density of the blackbirds. Alright, now in this question you are asked to comment on the reliability of this estimate. So since our product movement correlation coefficient at 0.907 is very close to 1, so we can say that there is a strong positive linear correlation between the woodland density and the farmland density. Now, and since x is equals to 380, which is in the range of values that we saw in the table for x, which stretches from 313 to 400, therefore the estimate is indeed reliable. Alright, so in part B of part 3, now you're given that the woodland density is 500. Alright, so using the same regression line of y on x that we have found earlier, we are able to predict the value of the farmland density of the blackbirds at 124.7. Okay, so therefore the estimated average farmland density for that particular year 1983 is 124.7. Now if you look closely, alright, the range of values for x that we talked about earlier was given that were observable from the table stretches from 313 to 400. Alright, so if you look closely at the value of the woodland density at 500, it does not actually fall inside this range of values. Okay, so in this sense an extrapolation has actually occurred. Alright, so when an extrapolation occurs, okay, the linear correlation may not be valid outside the range of the values of x. Okay, the reason being because whatever experiment data that we have collected, alright, and then we are able to form a linear regression line. Alright, now this linear regression line is only based on that set of data. So at x equals to 500, the data point 500 is actually outside that range. So we don't really know whether outside this data range the relationship is still going to be linear. So therefore we conclude for any extrapolation the estimate is actually unreliable. Right, now in part 4 we are required to determine which one of the variable is the dependent and which one is the independent variable. Now I've already let in during my earlier discussion on why x is actually the independent variable and y is the dependent variable due to the way that the question is actually phrased. So whenever we want to find out what is the independent or dependent variable, we need to actually look carefully into the context of the question. And in this question, it is said that counting blackbirds in the woodland is easier than in the farmland, and also it is used to actually predict the average density of blackbirds in the farmland. So in the sense, we are able to say that indeed x is the independent variable, and therefore in order for us to form the regression line, we will definitely need to do a regression line of y on x.